All right, buddy. This is All Things Engineering with your host, Randy Kaufman, PE. And today I want to talk about backwardly engineering a UFO. Now, everybody says, okay, it's 1947. We had a crash in Roswell. We found a UFO, and we were backwardly engineering a UFO from back then. Now, if I went back 500 years ago, and let's face fact, probably anybody that has interstellar travel is probably 400 or 500 years in our future. So let's go back 400 or 500 years. Find the smartest guy we had. We had Isaac Newton. Now, some people might claim it's Da Vinci. Da Vinci was he was a good researcher. He had a lot of great ideas. But Da Vinci he didn't know the mathematics. You know, the best bet you have is probably Newton. And Newton was brilliant. So, he understood the mathematics. He used to do alchemy even, which, was the forerunner of chemistry even. But now this was the best guy we had at that time, and he was at Oxford University. So he could have got together the other people in the university. And so now I'm going to go from the future and I'm going to bring like a smartphone. Doesn't matter what kind it is, just bring them a smartphone. Anyone, even 5, 10 years ago, bring him a smartphone. Well, now you're probably going to look at this thing like it's almost magic. And I mean, Bubba, you can go back and tell him, this is science, this is technology. I'm going to give you this. I want you to backwardly engineer this. Now, you have to understand this is just a smartphone. This, yeah, it's got a camera in it, it's got electronics in it that he's never seen. But that alien spacecraft is not only going to have inside of it, it's going to have stuff that's going to be way more advanced than that smartphone is. It's going to have, because it's going to have a communication device for the people. It's going to have engines in it, the material that's made. I mean, and so you give like Newton that. I mean, yeah, they knew how to make glass at that time, but they were barely making glass. Now you're talking about Gorilla Glass that's in this stuff that's way stronger than any kind of glass that you've got today. I mean, anything that you had for hundreds of years. Now, the electronics in it, they didn't even have a clue about electronics at that time. Now, and we go in and we're like, well, but we've got modern science, we know a lot more. And even though they're 400 or 500 years in the future, okay, they may have organic compounds that we don't understand. They may have the materials that they do. I mean, even like a smartphone, you couldn't build a smartphone in the 1940s. It would have been impossible. I mean, all we had at that time were transistors, didn't have microchips. And even today, even if you go back to like the 1980s and take on a smartphone, they couldn't build it back then even because you have you have to understand we're generations of machines ahead of where we were back then. We had machines that have miniaturized things that then make more machines that miniaturize other things. And that miniaturization was a process through machines throughout all those years. I mean, it's like when you first started out, I remember even back in the early 80s, I remember a guy that he used to do artwork for for motherboards and things. Well, it wasn't done with a computer. When they first started doing this, they took a big piece of clear plastic, they put it on a light board. And then what they would do is they would go in and they would sit down and they would take this black tape and they would tape across it and they would cut it. Now, this is how they built this. I mean, this to build the motherboards. And then what they would do is they would go in, take a photograph of it, and they would shrink it down to size. And then it would make it much smaller. I mean, that they couldn't have, I mean, the guy couldn't have did the artwork like that. Well, they don't do that anymore. They use computers to do that now. But that's what they had to do first of all because they didn't have the computers that could sit down and do the graphics and do the design work back then. I mean, you're talking about the first motherboards for the first computers. Well, that was a generation. And then after they got through making computers that were smaller, fast enough, and that they could do it, and they had the programs done, well, the artwork is now done on a computer. And then you shrink it down with the computer itself, not with actual photographs and stuff back then. It's just like when you go to a doctor today, when you have an x-ray done, they're not using film hardly anymore. I mean, yeah, there's some of them because they haven't updated their machines, and the old machines are there, they're paid for, and they still use the old film process and stuff. But most of your x-rays in most of the good doctor's office now, they're all electronically done. So that's a generation that went by and it's already gone. And it's just like in the 1980s, we learned how to make like bucket balls and carbon nanofibers, but we couldn't mass produce it. Well, that was 40 years ago. It took till recently before we can in the last few years, where we can mass produce carbon fiber. And now you can find it, it's dirt cheap. You can find it on desktops. The stuff is virtually indestructible. It's light, and it's a great material. Well, there's going to be materials like that in that spacecraft, probably only better. And I mean, we've got graphene that we've made in the last few years. Our material science has come along, but now it took years and years of development in each one of these branches, as far as like computer science, material science, all these things, to be able to produce these different type of items. And anything that's 500 years in the future that can go between interstellar space, it's probably got a lot more greater technology than what we even glimpsed of already. So the idea is, can I go backward? Can I go in and backward engineer this? It'd probably be impossible. You could probably give me the thing, and I'm an engineer, and I'm not that kind of engineer, but I understand the science and the mathematics, and I could probably get a team of engineers up. But I doubt very seriously there's a team of engineers on this planet. You brought them a spaceship 500 years from the future, and you set it down in front of them, unless they could not backwardly engineer it. The material sciences aren't there. It's probably for the equipment to make this stuff. I mean, it may be made in a certain way that we don't even have a concept how to make that type of material yet. And then the engines themselves and how they work, and anything that could do that kind of travel at that kind of speeds. I mean, you're gonna have to sit down. You're gonna have to figure out the engines. I mean, it may be that we may not even have right now the concepts for the physics to be able to do this, let alone be able to build an engine that does this. It may be 100 years in the future. Somebody comes along and they figure out some means of propulsion that we don't even understand today, and then with that propulsion system, then maybe the guy figures out like the physics of it. And then later on, people will start, maybe 100, 200 years in the future, they actually figure out how to actually build an engine based on that physics. And but we don't have. But you're talking about 500 years. Well, look at where we've been in 500 years, and our technology is growing at a much rapid pace than it is, back then. I mean, when you look, I mean, at what they had back then, and we would be just as primitive as a race that's 500 years in the future, but from us. I mean, they would be thinking, oh my God, you're fooling around with microchips and you're fooling around with this stuff. I mean, this stuff is so primitive. I mean, you look at our technology, and our technology that we had, okay, we had copper tools in Egypt. They finally, after about 2,000 years, they had iron tools. But when you look at the tools they used, there wasn't a big great advancement in tools. I mean, the Romans started making faucets and started having water and things of that nature. But really, when you look, even in the 1400s, when Columbus came over here, they were using sailing ships. I mean, sailing ships have been around forever. The Egyptians had them. So there wasn't a big leap in sailing ships between like 2000 something BC to today. There's a good indication that the Egyptians probably took their ships because they built really good ships, and they could have probably even made it to the Americas with their ships because they wrote about they sailed all the way around Africa. Well, if they could sail all the way around Africa, they could probably have sailed all the way across. If a big, especially if a big storm came up and it pushed them over into South America or something, they could have easily made it. But their ships, they built big, huge ships. That's how they took the blocks and built the pyramids and all that. They were really good shipbuilders. The Greeks were good shipbuilders. They all had sailing ships. But, there wasn't there wasn't like, even in the 1500s, there was not a big, huge leap in the technology for ships. The big leap came when they built for the first steamboats. And that was in the 1800s. That's when we started building trains. That's when we started building things that could actually go down the river faster. And then we started building boats that were coal powered, steam driven ships. But that was in the late 1800s. And so you look at what we have today as far as ships with all these passenger liners that hold all these people, and you look at what Columbus had, and it's primitive. It's like a joke. Well, the thing is, when you look at the technology from a spaceship like that, and a spaceship like that is going to be just something that lands here. It's going to be like a shuttlecraft to go down to a planet and go back up. And and then they're going to have a huge mothership out. Now, that's what's going to probably drive between the thing. I mean, it's like, the idea that you would land a big, huge ship that does interstellar travel, you wouldn't do that. But you would have smaller ships that would come down. But even if I found even the smaller shuttlecrafts that does this, the engines in these things would be probably futuristic. I mean, where they could do something with electromagnetic fields, if they could do some sort of gravity. I mean, there's always been talk of anti-gravity. If there's anti-gravity, it would have to have anti-mass. There's we've never found that yet. I mean, but you would have to have something like that because anything that has gravity is going to, it's the only way it would repel. I mean, according to Newton's laws. But now, it's just like give Newton this. I mean, he could take it apart. He could look at it. He wouldn't have a clue what those circuits in there are. He wouldn't have a clue about what all those little chips were. I mean, you could give it to him. You could give him even probably the schematics to the damn thing, say this is the way it's electrically wired. And they didn't even have a concept of like electricity back when he was around. And even if you go forward, even to like the 1900s, let's say you only go back 100 years. And I go to somebody like Max Planck, and I go to Maxwell or Planck or somebody like that. And let's say I go to where Einstein, Schrodinger, and Heisenberg, and all these people that are brilliant physicists, and they're working on all this stuff, and you give it to them. Well, they're theoretical physicists. They could probably break it apart. They could, you could probably give them the schematics, and they could probably say, okay, I understand how this thing works. And they could probably, if you gave them all the schematics, all the technical information, they could give them books and books about how this thing is built. They could probably come to understand how it's built. Could they reproduce it? There's no way in the world. Because they would have to sit down and first they would have to sit down and be able to make transistors. And we didn't have transistors then. We didn't have transistors. We had vacuum tubes. And that was the first basically a transistor type deal. And they shrunk it into a transistor. And then from the transistor, we got into microchip. So you've got to sit down and do this in stages. You have to be able to physically build this. You have to have plants that make. I mean, unless you're going to sit down and give them specs to plants and machines to make all these different parts. And then, they're going to have to make the first machines to build the second generation machine, to build the third generation machine, and so on and so on. This is going to take years. Even if you sit down and you give them everything, I mean, if you give them the exact details, of everything. And by 100 years ago, they had a good scientific concept. I mean, they were brilliant scientists back then. They were the ones that, Einstein did relativity, Schrodinger, Einstein, Bohr, Heisenberg, all of them. They did what quantum physics is today. And yeah, there've been some developments in it, but not, but they were the first guys that understood all this. And so you have some really brilliant people. But having brilliant people does not get you generations of building things. I mean, you're going to have to sit down, you're going to have to make this generation of machines. And the first thing you would have to probably do is say, okay, this is this is how you build uh, transistors, and from the transistors, then they would learn how to build much smaller radios and things of that nature. And from there, you could sit down and say, okay, this is how you build microchips. Well, they're going to have to build microchips, and they're going to build the first computer. Now, this is not going to be something quick. I mean, even if you throw a lot of money at it and you tell them what all you can achieve with this, you're still going to have to build the first generation of computers. You're going to have to program those computers. And I mean, and when you start looking at what we've done, I mean, it's like the first thing they did was machine language coding. Incredibly hard to understand machine language coding. I mean, it's not easy. I mean, it's hard to program in machine language. And then, but then from the machine language code, then they started getting into things like C++ and things like that. And there were generations of those things to program the stuff with when we built the computers. And all that is going to be like that with that spacecraft. There's going to have coding in there and programs and stuff. And, and of course, it's not going to be in the programming languages we know. And besides that, it may not even be a computer like we understand. I mean, they may have quantum computers. They may have computers that are not just binary. And, and so they may have solved all of that. And so we're just now starting to understand quantum computers, but they may have something even beyond a quantum computer. And we don't know what kind of computer technology is in the thing. I mean, there is a lot that goes into building anything that 500 years in the future that we wouldn't have. I mean, you think about what our technology was 500 years ago and think of what our technology is today, or even think about our technology 100 years ago and what it is today. And then think about, oh, well, this advanced race from another planet came here, and I got a ship. Yeah, I got a ship. Do I have all the technical manuals for all the plants and the factories and everything that went into building this thing? Of course I don't. And I've got an example there. And there's a difference between backwardly engineering something that is close to your technology. Like if, let's say the Russians develop some new hypersonic missile that they claim that they developed. And we've been working on it. It's just not real stable. But I could sit down and I could develop a hypersonic missile, in the United States with a good set of engineers. I could do that because it's not very far off from the technology we have today. The material sciences are not going to be extremely more advanced. So let's say the Chinese develop something, and I don't know how it does. But I don't know exactly how it works, but they give me it. Well, it's going to be close to my own level of technology within a few years. Let's say, in the United States, I'm going to develop this independently another 3 years down the road or another 4 years or whatever. But it's close. And, and because it's close, because I have machines that are close to that same level of technology, I can do that. But to be honest, it's like, go back to the Apollo era and, and bring them an iPhone, even then, they were, I don't think people understand, during the Apollo mission, even only 50 years ago, they were using slide rules. They didn't have calculators. They had teams of people working on math to actually sit down and do all this. And, and they were in the basement of buildings and they were sitting down and they were using all the gravitational formulas, calculating all these launches up and what they had to do. And that's what they did. And, well, today, a computer does that and it does it really easy. But that's was only 50 years ago. Even if I took my iPhone or a Samsung phone or anybody's smartphone today and I carried it to them back then, they had, when Neil Armstrong almost crashed into the moon, that's when they decided they needed a better computer. I mean, the computer on board of that thing wasn't even as good as like a Casio watch that was back in the late 80s. I mean, you had the little calculator on the watch. I don't know if you remember all those old ones, but it was nothing like even a watch today. Nothing like a smartphone. I mean, the whole system thing was like, I mean, even the smartphone of the day, if you go back about 20, 25 years ago, is a supercomputer. That's how much computer science has advanced in this length of time. And so, if you went down and you carried a smartphone back 25, 30 years ago, they go, this is a supercomputer. And this small, instead, they were paying hundreds of millions of dollars for a supercomputer that took up rooms, had to be super cooled and all that because they couldn't run the calculations that like even a smartphone could. If you look, like when I went to college back in the 80s, well, what did I have? I had an 8088 sitting there. And I remember when they got to 286s, and I thought, man, these things are really fast. They're really incredible. They run 14 megahertz. 14 megahertz. You're talking about a smartphone today, it's not got one core chip in it. Even the smartphones have 4 and 8 core chips. So there are 4 and 8 cores working instead of one that was in that 286. I know there's a lot more of the computers out now that have a lot more cores than that. And, so then on top of that, they had very little bit of memory in it. I mean, a meg of memory was a huge amount of memory. And a meg now is absolutely nothing. You're talking gigabytes of memory, not megs. We're talking thousands of times more memory. I mean, most computers have like 16 gigabytes in them at least. Your phones have 8 gigabytes. That's 8,000 times more memory than what you had in a 2000 something desktop computer from only about, these were out in the late 80s, so that's only about 35 years ago. And so you had this big hulking machine that sat there. There was no graphics cards in them, and if they had a graphics card, they could only do like 256 colors, where you've got literally millions of colors in a smartphone. You could never hook the thing up to a internet. You didn't have an internet back then. They had a thing called BBS, which was close. It was the forerunner to it. But you could not take an old 286 and you could not today hook that thing in with like a LAN card and hook it into the internet and even sit down and display and run videos. And here you are, you're watching this either on a TV for like $200. You're watching it on a phone that you paid. You can buy a phone now for $100 and something that will still stream this. Now, you're talking about that's the leap in your technology in only like 35 years. But in that 35 years, we went from taking one set of machines to make another set of machines to make another set of machines. Now, so that took 35 years to do. And you're talking about, you're talking about a machine that will set down like your phone. That smartphone is just as powerful as supercomputers were back when I was in college. Probably a lot more powerful. I mean, I can remember the mainframe that we had in college. They were still renting. And that mainframe had 1 meg of memory. It run 14 megahertz. These run in the gigahertz, which means it's 1,000 times faster. That had 1 core CPU in it. These have 8. Then they're running around 4 to 5 gigahertz. So you're talking about 5,000 you're talking about 5,000 megahertz. That's what that's equal to. And so that is a lot faster. I mean, and then you have all those cores that are running all that stuff at the same time. So you're looking at, got 8 cores running, when they start running like 4 and 5 gigahertz, you're looking at 32, 40 gigahertz at one time is what you're actually getting as far as processing power. The speed compared to today, compared to back then, is incredible. But it took generations and generations of this. And this is common that we walk around with this and we don't even understand it. The engineers do that work in this particular field, but the engineers that work in this particular field, it's just like the guys that make the glass for these. There's a set of engineers that make the Gorilla Glass. Well, they understand how to make the Gorilla Glass. There's another set of engineers that understand the cameras and the camera technology. There's another set of engineers that understand the microchips and the CPUs. Another set of engineers that understand the memory functions. Another set of engineers that understands the IP, that understands the Bluetooth, the Wi-Fi, and each one of these, they take all these different engineers to design all these different parts for this thing that goes into this. And so you have another set of engineers that develop the screens for the touch screens and all that. So you have a lot of different types of engineers that worked on this. Most of them, and they're electrical engineers, except for maybe the glass might have been a mechanical one, but he was probably a mechanical engineer. But all these engineers worked on this to produce these smartphones. Now, the smartphones that they produce, as anybody would well know, I mean, look at the smartphone we had from 10 years ago, look what we got today, and you see the difference in them. They're big leaps in these things, just like there were big leaps in the computers. And so each time that these things got better, I mean, it's just like with the chip. The chips have gotten smaller and smaller and smaller all the time. And, they went from like 40 nanometers down to now, I think I read that they were doing like there's 4 nanometers in size, so they've gotten 10 times smaller. And this has not been that long of time period. But to keep shrinking this stuff like they've done, they've had to keep making new sets of equipment to do this. And when they do that, these machines that do this, they were generated through computer software. Well, there's been tons of software engineers to develop the smartphones too. And now you think that's just a smartphone. That's all that thing is. Now, that UFO is going to have things like these smartphones in there, only a lot more advanced. They're going to have computer systems in here, a lot more advanced. They're going to have propulsions in there, a lot more advanced than what we probably even understand today. So, I think it's kind of absurd to think, I got this piece of equipment here and I can backwardly engineer this. I may not even understand the fuel source that goes into this thing, how this thing, I mean, you look, we've been researching fusion to do fusion, and we understand fusion from, my God, we did fusion reaction with nuclear bombs back in the 1940s, and we've had fusion reactor plants now that've been powering, countries around the world for a long time. We wanted to get into fusion because there's a lot more energy and it leaves no radioactive material. We've been researching fusion reactions now for probably 50 years. We still don't have a fusion reactor that works. I mean, it'll work for a few seconds and you get a little bit more energy out of it now than it used to out of some of them, but it's not tremendous because they can't keep it stable for a long period of time. Well, you think 500 years in the future, it's probably not a fusion reaction they've got. It's probably some other kind of, it's probably they're getting their energy from something else. I mean, they may be able to draw, we think we can actually draw energy from empty space with a Casimir effect. But, they may be able to do that. I mean, there's all sorts of possibilities for energy, in the future that we think we could actually do, but we're not there yet. And, so we're going to have to be, we would have to be closer to their technology level. And if we're that close, we're not going to be stuck on planet Earth. We're going to have interplanetary flights. You know, we may not have interstellar flight, but but we're going to be. By the time we could be able to understand something like a UFO that landed in Roswell. That's 500 years or 400 years in our future. Well, we would need to be at least a lot further along in our own technology. It's got to get closer to be able to understand that. But no, I mean, there's no way that you could backwardly engineer this. Like Newton couldn't backwardly engineer a smartphone. Hell, we couldn't even probably I mean, I couldn't go to Planck's and get Planck's to do it. I probably couldn't get Einstein or anybody else, even from 100 years ago, to do a backwardly engineer a smartphone. I mean, like Tesla was doing some of this, and they might be able to take it apart and they might understand the circuitry and all that. And so they would look at that little tiny circuitry in there and they would go, how in the hell did they make this stuff this small? Is what would probably get them. I mean, if you took the chip out and cut it open and looked at a microscope at all those little transistors and stuff in there, and even if they had the concept, even if you gave them what the transistor concept was, when they started looking at that, and they looked at all those little transistors, and they would be dumbfounded. They would be like, how in the hell could they shrink something down this small? And they would probably think, this thing didn't come from 100 years in the future. They would have thought maybe this thing come 500 years in the future, because our technology has been growing at such a rapid pace in the last 100 years. And and maybe, but our technology is still nowhere close to getting us to having interstellar flight. And I mean, to get interstellar flight, we're going to have a lot more advancements than what we got today. But no, I mean, I think it's silly when people say, we backward engineered this UFO from Roswell. Well, I don't think so. I mean, that would be almost an impossibility. But guys, thanks for watching. Remember to give it a thumbs up if you liked it and subscribe to the channel. I got a lot more stuff I'm going to do up.